In this video, we're going to talk about the greatest common factor. So, a factor is an integer that is written as a product of two or more integers. 1 and 10 are factors of 10 because 1 times 10 is 10. 2 and 5 are factors of 10 because 2 times 5 is equal to 10. Well, this is also the case for polynomial expressions. So x plus 3 and x plus 2 are factors of this trinomial because x plus 3 times x plus 2 equals x squared plus 5x plus 6. 5 and x squared plus 3 are factors of 5x squared plus 15 because when you multiply 5 and x squared plus 3, you get 5x squared plus 15. Okay, factoring. This is the process of writing a polynomial as a product of polynomials. Think of factoring as the reverse to multiplying polynomials. So earlier in the course, I gave you x plus 3 times x plus 2, and you gave me x squared plus 5x plus 6. In this chapter, I will give you x squared plus 5x plus 6 and would like you to factor it down to x plus 3 times x plus 2. So the first step in factoring any polynomial is to factor out the greatest common factor. And the greatest common factor is the largest factor that can be divided out of all terms. Okay, so let's determine the greatest common factor. Well, one way I can determine the greatest common factor is to create a factor tree to get all the prime factors of a particular number. Well, for instance, 16 I can break down as 4 times 4, and the 4s I can break down as 2 times 2. So 16 is 2 times 2 times 2 times 2. 28 I can break down as 4 times 7, and again 4 I can break down as 2 times 2. So what factors do they have in common? Well, they have 1 and 2 factors of 2. So the greatest common factor is 2 times 2, which in this case is 4. Okay, the other example, this one I've included variables. So 25x squared I can write as 5 times x times x. 35x cubed, that's 5 times 7 times x times x times x. 100 might be a little bit more involved, so I'll do it up here. So 100 is 10 times 10. And 10 I can break down as 2 times 5. So that's 2 times 2 times 5 times 5 times x times x times x times x. So what do all of these terms have in common? Well, 5, x, and an x. So the greatest common factor is 5 times x, which is 5x squared. Now, let's go back to the example. Every single one of these terms had factors of x. Okay? The exponents were 2, 3, and 4. Well, in the greatest common factor, it ended up being 2. So if each of the terms has the same variable factor, we'll write the factor down with the smallest exponential power. So I've written that here. The GCF of variable expressions is the variable raised to the smallest exponential power. Okay, so then let's factor completely then. So the first example with these two terms, what is the greatest common factor I can take out of those two terms other than 1? Well, that's 3. So the GCF is 3. So the 3 goes on the outside, and I'm going to divide 3 into each of these terms. So 3x divided by 3, that is x. 12 divided by 3 is 4. I can't factor the inside any further, and we're done here. Now, you can check your answer by multiplying. Well, 3 times x is 3x, and 3 times 4 is 12. Okay, let's go to the next example then. What is the greatest common factor I can take out of all of these terms other than 1? Well, numerically, 25, 15, and 5, that is a 5. Every single term contains a factor of a. So now we take a look at the exponent powers. 4, 2, not 1 here, so that exponent power is 1. So it'll be 5a. So again, the greatest common factor goes on the outside. I will divide 5a into each one of these terms. 25a to the fourth divided by 5a, that is 5a cubed. Remember, when you divide exponents, you subtract the powers. 4 minus 1 is 3. 15a squared divided by 5a, that is 3a. And 5a divided by 5a, no, that is not 0, that is 1. Going inside the parentheses, I cannot factor any further, and we're done here. Okay, one other example I want to take a look at. Is there a greatest common factor I can take out of all of these terms other than 1? Well, the answer to that is yes. Notice, the first term has a negative, so automatically I want to take out the negative because I'd like the leading coefficient to be positive. Okay, let's take a look at the numbers. 9, 18, and 27. Well, that is 9. I can divide out of all of them. Each term contains a variable of x, so look at the exponent powers. So that's 1, 2, and 3, so that'll be x to the first. Every single term contains y's, so let's look at the exponent powers again. 6, 5, and 4. I can factor out y to the fourth. All right, so the greatest common factor goes on the outside. We will divide that into every single term. 9xy to the sixth divided by negative 9xy to the fourth. Negative 9 divided by negative 9 is 1. X divided by x is 1. Y to the sixth divided by y to the fourth is y squared. 18x squared y to the fifth divided by negative 9xy to the fourth, that is negative 9. X squared divided by x is x. Y to the fifth divided by y to the fourth is y. And then 27x cubed y to the fourth divided by negative 9xy to the fourth, well, that is negative 3. X cubed divided by x is x squared. And y to the fourth divided by y to the fourth is 1. I cannot factor inside the parentheses any further, and we're done here.